A uniform rod XY of weight 10 Newton is freely hinged to a wall at X. It is held horizontal by a force F acting from Y at an angle of 30 degrees to the horizontal as shown. What is the value of F? Okay, so this is the uniform rod XY and it's hinged to a wall at X, and there is a force F that keeps the rod in the horizontal position. And this is the force that we need to find. Now, since the question says that the rod is held horizontal, that means that it's held, basically it's stationary, that means it's in equilibrium. And in order for it to be in equilibrium, these two conditions should be satisfied. The forces and the moments should be balanced. In order for any object to be in equilibrium, these are the two conditions for equilibrium. The forces and the moments must be balanced. So let's look at the forces first. This is the force F given, and this is the weight 10 Newton given to us. No other force is shown on the diagram. And if you think about it practically, there must be a force acting at the hinge as well, but it's not shown in the diagram and we're not sure what should be the direction. So the forces part is causing a confusion. So let's leave that. Instead, let's look at the moments. Now, in order for moments to be balanced, the clockwise moments must be equal to the anti-clockwise moments. So we can construct an equation like that. Okay, for that, before doing that, I need to resolve the F force into its components, the horizontal and the vertical components, and I would name them as F sine 30 for this one and F cosine 30 for this one. Now let's consider the forces and their respective moments. This force would cause an anti-clockwise moment, and this force, the weight force down below, must cause a clockwise moment. And that's it. This force, F cosine 60, will cause no moment. The reason? Because the line of action of this force is passing along the hinge, which is acting as our pivot point. All right, so these are the two forces. Let's consider their moments. The formula for moments is force multiplied by the perpendicular distance from the pivot point. So the distances are not given to us, right? So let's consider a very rough distance. Let's, name it as L. Let me name this entire distance as L. So the anti-clockwise moment should become F sine 30 multiplied by L. And the clockwise moment should become 10 multiplied by L upon 2. Look at the diagram. This is the weight which acts on a uniform rod, meaning it acts exactly at the center of the rod. So this distance would automatically become L upon 2. So I now have this equation. L and L would cancel each other out. Don't worry about the L's, the distances. Students usually get confused over here. They think that we don't even have the distance, but it's fine. It's going to cancel out. So that's it. Let's solve the equation. 10 upon 2 is equal to F sine 30. 10 upon 2 is 5. And 5 divided by sine 30 would give us 10. Yeah, sorry, 10 Newton is our answer. And that's option C.